Okay, question 10. 10 couples took part in a dance contest. Couples are given a score in each round, and the scores in the first round were this. So, pretty big scores. Presumably, it's out of 100 and they're all rubbish, or it's out of 30 and they're still a bit rubbish. But yeah, calculate the median and semi-interquartile range of these scores. Okay, I love these questions. I just think it's very prescriptive. Same stuff, similar to the standard deviation. Um, yeah, you just got to work through the kind of program. Okay, so whenever you see this kind of data, the very first thing I always do, write it out in order from lowest to highest. Okay, so we've got 12, 16, and 17. And as you write it, just score it off up here, just to check that you've not missed anything out. And then we've got 18 and 18. Okay, looks good to me. And then we've got 21 and 22. Just scored out. 26, 27, and a final 27. Okay, and then your very last check, just count them up. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good stuff. So calculate the median. Okay, now before we calculated the mean, okay, so the mean was adding up all these numbers and dividing by 10. Okay, that was the mean, which we did for the standard deviation question. The median is what would be in the middle, okay, of a data set. Okay, now it's interesting. People talk about, they always say the average of numbers, but really, usually what the average is the mean. Okay, it's adding up everything and dividing it by the number. But there are different forms of average. Okay, you could have the mode, which is the most common result. You could have the mean, which is adding them up divided by the number, or you could have this, the median, which is the number in the middle. Okay, it just depends on the data set you've got. Okay, the more skewed the data, the more useful these different indicators are. Okay, so again, I just kind of talk around the question for a bit of, for a bit of fun, a bit of general knowledge. But yeah, the median is just basically find the middle number. Okay, so difference between 21 and 18 is 3, so let's half that, 1.5. So I know that in here, that's going to be 19.5. Okay, 19.5 sits exactly in the middle of 21 and 18. Okay, it's a difference of 3 between them, so I half the difference and then add it on to 18, or half the difference and take it away from 21, 19.5. Okay, if there was an odd number of data, so say there was 11 numbers, it would just be the very middle number. Okay, cool. So that's us done our median. Right now it's a semi-interquartile range. Now basically we do the same thing again, but for half the data. Okay, so this is split the data in half. And what the interquartile range is looking for your, first of all, you're finding your quartiles, which is kind of like the median of the bottom set of data and the median of the top set of data. So I've got 5 data points here, and I've got 5 data points here. Okay, so this is like my bottom set. Okay, and this is my top set. So Q1, which is from my bottom set, is obviously going to be 17. Okay, so that's the median of the bottom set of data, if you like. Okay, that's what you're doing with these numbers. Obviously, for the top set, it is 26. So there we go. I found my median, which is just the middle number, and then I found my quartiles, which again is the middle number of the top and bottom sets. Okay, so you're just finding the middle of the middle. Okay, for these ones effectively. Okay, and then you're looking for your semi-interquartile range. Now, the interquartile range would be Q3 take away Q1. Okay, so interquartile range is saying what's the difference in the quartiles? That's going to be 26 minus 13, isn't it? So that's going to give us 13. Okay, so it's basically saying, well, the interquartile range would be from here to here. What's the range from here to here? The semi-interquartile range is that number halved. Okay, dividing it by 2. Okay. Just noticed that, nope, I made a wee mistake. I've written that number down wrong. Whoopsie daisies. Sorry, that should be 17. Sorry, so that is going to give me 9. Isn't it 3, 6, sorry, 9. Whoopsie daisies, sorry. Again, I can restart these videos, but I do got just to show that as I'm going through them, I kind of look at the numbers and now and again I'll spot a small mistake. So yeah, so between 26 and 17, that's going to be 9. Okay. But the semi-interquartile range is almost like the distance from your quartile to the median. Okay, so it's actually, you're dividing that by 2. Okay, 4.5, that's going to give us, right? So just the interquartile range is saying, well, what's the distance between my quartiles? What's 26 minus 17? It's going to give me 9. The semi-interquartile is then half of that. So it's kind of like the average distance from the median to your quartile. It's kind of like that. Okay. So yeah, that should be all 3 points. And no surprises on the marking scheme. You're getting a point for your median. You're getting a point for your 2 quartiles. And then you're getting a point for just working out your semi-interquartile range. Okay. There's not really a lot more they can ask you on that. Sometimes they ask you to draw it out. Okay. So if we were to draw that out as a box plot, we would have, first of all, our range. Okay, so we'd say 12 is an extreme, and 20, I'll just draw it kind of in line with the number, like 27 is an extreme. Okay, so you've got that. You then want to show where the majority of your data is, and the majority of the data for us is between 17 and 26. That's what the quartiles are. Okay, and then you'd mark on your median 19.5. Okay, that's kind of, if you were trying to draw it out, this is what you would draw. So the box plot is the boxes where most of the data is. Okay, it's between Q1 and Q3, and then you've got your two extreme numbers, 27 and 12. So the range for this would be 27 minus 12, which would be 15. Okay, but yeah, if you had to draw it, which is the only thing they've not really asked us to do in this question, you would be you'd be doing this thing. So the point is to know that your box starts and ends at Q1 and Q3. It should show the median, and then you've just got a single line out to the extreme values. Okay, so yeah, don't need that for this, but if you were drawing it, that's what you would do. You'd pick an appropriate scale. Okay, I've just tried to draw it in line with these numbers just to make it clear what's going on. Okay, so this is the whole point of working these numbers out. It's to try and show where most of the data is. Okay, these are extreme values. And this is where most of the data lies. So in another round in the dancing, the median was 26 and the range was 2.5. Make 2 valid comments. Okay, well, before the median was 19.5 and now it's 26. So it's gone up, hasn't it? Okay, so I'd be saying on average, in round 2, the dance scores were higher. And notice I've not said, the medians were higher, because that's not really answering the question. It's trying to get you to think about what the question means. Okay, so before the average score was 19.5, and now the average score is 26. So they're dancing better, or they've been giving better scores. Okay, so on average, which is the important thing to start your question off, and then talk about, put it into the question as much as possible in round 2. So you're talking about this one here, the dance scores were higher. I could have said in round 1 the dancing scores were lower, but make it as much about the question as possible. Okay, the interquartile range was 4.5, and then it was 2.5. So the range, like I said before, is like this box plot here, isn't it? It's like from here to here. Okay, so sorry, the semi one is from the center to the edge, I suppose. But if you imagine the box, really, the bigger the interquartile range, the bigger the box. So our box has now gotten smaller, okay, because we've got a smaller range. So we've got a smaller range, we've got a smaller spread of results. Okay, so it's like a more consistent set of results. Okay, so not only are they scoring higher, in round 2, the scores were more consistent. Okay, they're more consistent. Or you could have said in round 2, there was less of a spread of results. Obviously, your handwriting should be better than mine. Okay, it's hard to write with this pen. Okay, believe me, it's really, really tough. I'll just rewrite that because it was annoying me. Spread. Okay, so less of a spread or more consistent. That's the two phrases. I could have said in round 1, the results were less consistent, but there was more of a spread. I could have said it that way as well. Okay, so it's tricky to teach yeah, to teach this one because obviously the context changes all the time. Okay, so what I'll do is like I'll highlight so you always want to say on average, right? And then the next bit, this is really the context. Okay, so in round two, the dance scores. All right, that's the bit that's going to change. Okay, so a favourite one's like rainfall. So I might say, in the second place, in Glasgow and Edinburgh, the rainfall. That's the bit that's going to change depending on the question, and then depending on the actual numbers, you're going to say higher or lower. Okay, so that's the kind of format you want. On average, question was higher, was lower. Okay, and again here for the consistency question, we're going to say in round two. So again, that's the kind of the scores. That's the question, and then this is the bit you always want. We're more or less consistent. Okay, so those words should all really be the same all the time. The bits in blue, but just the phrase was it higher or was it more consistent? They'll change. They'll be higher or lower or more or less. Okay, but you really want to stick to this kind of template. Okay, and remember the on average. That's important as well. Okay, um, yeah. So just make sure you use the question. Don't just say in round two the mean was higher. I don't think you get the mark for that. Okay, you need to say that the on average in round two the dance scores. Okay, it's all about if you said the word scores that'd be okay. But I'm really tying in the dance scores. What we talking about? Is it the rainfall? Is it the number of trucks? Really tie it into the question. Don't just say the mean was higher or lower. Okay, I think the second one's easier to kind of. No, that's not really. They both have to tie into the question. Okay, the second one's just added trickiness because a lot of people see that the range goes up, and then they think that means by the range going up, it's more consistent. Okay, but actually, if the range was to go up, it's less consistent. It's like the opposite. That's something that people get confused with. So we've gone from a range of what was it 4.5 to 2.5, so our range has gone down. So people might say, oh, it's less consistent because the range has gone down. But if you think in the range has been this box, the box is getting smaller, so it means all the results are concentrated in that small area, so that's more consistent. That's probably the only bit that can trick people out. Okay, I don't have time to go into this question, so brilliant question here. Put them in order. The median is the very middle number, and then your quartiles are the middle of the top and bottom sets of data. Okay, if you don't have a middle number, it's just a number that you calculate in between two numbers. Okay, your interquartile range would be Q3 minus Q1, but the semi-interquartile range, which is actually what you usually ask for, you have to divide that by 2. So Q3 minus Q1 is kind of like this length here of the box. Yeah, your semi-interquartile range is kind of like the average distance from the median to the quartile. Okay, so on average, 4.5 from here to here. Okay, and see obviously then it's bigger. This is 6.5 and that is 2.5. So on average, 4.5. Okay, that's kind of what we're working out. And yeah, tie into the question: a small interquartile range or a small a semi-interquartile range or a small interquartile range or just a small range. The ranges doesn't matter which one you're looking at, but the smaller the range, the more consistent. Okay, more consistent means less of a spread. Okay, so I hope that was helpful.